What's the smallest thing you can think of? An ant? A pebble? A grain of sand? Well, would you believe that there are things much smaller? Xing is a professor at Rensselaer Polytechnic Institute, where he works on big ideas on a very tiny scale. So small that it is 1 million times smaller than an ant.
So my name is Xing Wang. I'm a scientist working on so-called structured DNA nanotechnology and its applications in other fields like biology, engineering, physics.
Nanotechnology, or nanoscience, is the study and making of very, very, very tiny things for many different uses. So what are some examples?
And the nanoscience are also used these days for drug delivery, drug discovery.
What exactly is drug delivery? Drug delivery is how medicine gets to the place you want to treat without harming the rest of your body. For example, when you get a shot, the medicine goes directly into your veins. Your veins are like highways, and they spread the medicine all over your body. But for some sicknesses, the medicine is really strong, and it can be harmful to healthy parts of your body. This is where drug delivery is helpful. The drug delivery systems that Xing works with are like cars on the highway. They keep the medicine inside until it gets to the right place and stops the medicine from going to healthy parts of your body. The cars that Xing uses for drug delivery are made out of DNA, which are large molecules inside of your cells. The DNA can fold up like origami to create different nanostructures. In order to make these DNA nanostructures, Xing uses long pieces of DNA called scaffold strands that create the structure. Then he uses shorter strands, called staple strands, to secure the shape he has created, just like how you staple pieces of paper together. He also uses nanoparticles to shape the DNA structures. Xing can use DNA to design nanoscale objects because they have special properties. When objects are that small, you can't easily just pick them up and move them. So scientists like Xing need to understand chemistry and physics to use the object's properties to move it around the way they want to, in order to make many different shapes at the nanoscale.
Stepwise, we can first draw the blueprint of the objects you are interested in building for specific purpose or applications. You can lay the long single-stranded scaffold strand along this blueprint you print it on the paper. Then you basically place other staple strands around this long scaffold strands.
Once the shape is created, you can fill your nanostructure with medicine, close it, and send it on its way to test it. In this design challenge, you will be making a DNA origami-inspired structure out of pasta, pipe cleaners, or rubber bands that will hold some medicine that will be delivered along a zip line.